So today we are going to discuss about um, the topic of Laplace transforms. See, there are so many transforms are there. For example, Fourier transform, then Laplace transform, some of the others, and then Z transform. So we have a lot of transforms. Why we need transforms? First of all, why we need transform? Because the value is the only value that is there is no use because of the mathematics. Basically, that is the equation. We have to. That is the equation. For example, x square plus 2x plus 3. So this is the one of the equation. We have to all the mathematics, even the numbers, all the mathematics, we have to convert it into the equation. Why we need equation? Because all the computerized, whatever we will give the input values, right? We will give the input. All the values are we have to only with input with the equation, right? So whatever we need the big three values are whatever the computer science domain, whatever we have to give the program, we have to values we have to convert into a equation. Okay, so that equation, so whatever the values we have to give the input of program, that we have to convert it into a equation, right? So we have a converted into equation. There are a lot of types because, for example, even the robotics, we have to create we have a take model of robotic. So that robotics it moves and that robotic we shake the hand, right? So for example, that robotic will take the something in this node, right? So this will be moving on maybe the 30 degree, right? We have to give the input of that robotic will take the anything. We have to give the degree of 30 degree. So that 30 degree we have to give the instruction 30 degree. Maybe it will comes error. So what are the errors are there? One is the positive error, then another one is negative error. So that positive error like 0.0, it means 31 degree, it will go to 31 degree or it will come to 29 degree. So it will be going to the beyond the 30 degree, we have to reduce the values, right? And then it will come the error of 29 degree, we have to increase the value, right? So we need the 30 degree. That's all. We give the instruction of 30 degree. So maybe the error will comes ups and downs. So in this we are using a lot of transforms. For example, Laplace we can use that. Otherwise, Z transforms we can use that, and then first the transforms. So if we can use the good transformation, that easily the outcomes will come very easy. Okay, so all the three things, for example, Z transformation, and then here Fourier transformation or Laplace transform, whatever transformation we can use that. But the values comes accurate, we need the few things. For example, heat energy. That time we can use the Fourier transform. That is that Fourier transform only will give the good result, right? And then other thing, that the control system. So system controlling, that we can use the Laplace transform. That will give the good result. Okay. Then because we are using that, see, for example, give that. See, in this we can open this mobile apps. Did you notice that apps? See, there so many apps are there. But if you see that, see, we need to open to the WhatsApp. We have to give the only on WhatsApp, for example, that outline. See, outline of the WhatsApp, then after boundary. After the boundary, we can, wherever you put, you can touch, that definitely that WhatsApp will not open. But inside the boundary, so inside the boundary, if you touch that WhatsApp, then WhatsApp will be open. So who will fix the boundary? That is the Laplace, right? We will fix the boundary in Laplace system. It's accurate value because even the single touch of even the 0.1% of extra boundary, it will not open. That is the Laplace transform, sir. Energy, right? So wherever you touch that boundary value from that one is the Laplace transforms. See the using Laplace transforms, the boundary, the acute value is given only in this possible of Laplace, right? So that is the uses of Laplace, and we need the use of Laplace so many things in aircraft, because aircraft everything the road will be a very accurate value, right? So aircraft will be open area, no, it is a closed area, so that is also we need the route very the boundary will be very accurate, so that also we can use that Laplace. Okay, thank you.